Between 1930 and 1940, the United States started their commercial sale of liquid dish soaps. We all know that dish soaps are made to grip onto the fats that are on our dishes and cutlery, and we all know that milk has fat in it, unless of course it's skim milk. But have you ever wondered what would happen if you placed dish soap in milk? Well, while I was viewing an episode of Steve Spangler's Science, I came across the idea of color changing milk. I then wondered what would happen if I varied the level of milk fat in the milk I used, and then placed soap into the milk. This led me to pick out 5 different types of milk, each varying in their level of milk fat. Giving me my research question. My research question was, which of the following milk types will create the greatest and longest chemical interaction between the soap and the milk? Skim milk, 1% milk, 2% milk, homogenized milk, or raw milk? Raw milk was tested and had a fat content of 4.69%. Well, I considered it, and so my hypothesis was born. My hypothesis was that raw milk would have the greatest and longest chemical interaction between the soap and the milk. You may be wondering what I mean by chemical interaction. Allow me to explain. A chemical interaction is a kind of action that occurs as two or more objects have an effect upon one another. Conversely, a chemical reaction is the process that permanently changes an object's molecular structure by means of losing, gaining, or sharing of electrons. Thus, as you'll see, my experiment would best be categorized as a chemical interaction. Now let me explain to you the process by which this interaction occurs. What happens when you wash your hands? Well, soap is made to grip onto the fats, oils, and grease in your hands. You then use water to wash it away. The same thing is happening with the milk. When the cotton swab of the soap touches the milk, the chemical interaction between the soap and the fat happens. The soap latches onto the fat in the milk and tries to bond with it, causing the turning and swirling in the milk, which the dye highlights. Also, when the cotton swab with the soap touches the milk, the surface tension in the milk is broken. The Macmillan Dictionary states the definition of surface tension. Surface tension is the force by which the molecules of a liquid stay close together at the surface to form the smallest possible area. Therefore, when the cotton swab with the soap touches the milk, the molecular structure of the milk is broken, contributing to the turning and swirling of the milk. Let me briefly explain my procedure. The first thing I did was to pour 1 cup of each milk type into each pie plate, washing the measuring cup every time I used it. Next, I put 2 drops of red, yellow, green, and blue food dye into each pie plate. I would then take 5 Q-tips, also known as cotton swabs, and dip one end of each Q-tip into one of the bowls of dish soap. I would then place the end of the Q-tip that had the soap on it into one of the bowls of dish soap. I would then time the interaction starting when the Q-tip was placed in the milk until there was only a trickle of movement. During this, I then repeated the procedure with the rest of the milk types using a different Q-tip and bowl of soap each time. During this, I recorded my observations in a notebook and took the photos and videos needed to complete my project. I then transferred the data onto my laptop and recorded it in tables and charts. I had many interesting observations, but one in particular intrigued me. While all other milk types, after finishing the reaction, would have their colors morph, the raw milk kept roughly a centimeter of pure white milk that stayed untouched by the food dye for hours. After much discussion and research on what might have caused this reaction, I now know the reason that raw milk had this reaction. The reason raw milk had this reaction was that God made everything perfect in its natural state, and when we mess that up, in this case pasteurization, we destroy the perfect symmetry God intended it to be. I enjoyed finding the answer to this question and others like it. However, during my experiment, I did have a few challenges, one of which involved an outlier. I was trying to do too many things at once and received an odd timing. My charts proved my hypothesis half correct. I had assumed that the milk type that had the greatest reaction would also have the longest reaction, and the one that had the longest reaction would also have the greatest reaction. But I found this was not the case. As raw milk did have the greatest initial burst, homogenized milk had the longest timed reaction. In fact, I was able to notice a trend when I looked at the graph results. With the exception of the raw milk, all other milk types, after finishing the reaction, all other milk types involving pasteurized milk showed that as the fat content in the milk increased, so did the time of the interaction between the soap and the milk. Out of curiosity, I did a cream test involving 10%, 18%, and 33% cream. I also did an extended test, watching until all the movement in the milk had stopped. Another interesting study might involve buttermilk, or products that contain milk like wet plastic solutions and glue. Thank you very much.